simple interfaces, power, PTT, but in and out, so I can use digital modes, 2-meter IF, and then the RF connector. Always include a front panel meter for relative transmit power output reading, so you know you're getting out when you're in the field, and then have some fun building. I like to build things, and this was right in line with that. Approach I took was to use the 2-meter IF and program an ADF 4351 eval board or development board for 3408 megahertz and use a 10 megahertz reference, and then build up a W1 GHz times 3 multiplier to get the 10224 megahertz LO that's needed for the 2-meter IF. I wanted to use a good 10 megahertz OCXO reference, so I'd have stable operation from that, and then also make an easy transition to a GPS DO if I have that in hand out in the field. Then build W1 GHz 10 gigahertz transverter board for the basic low-level input and output sections, and then add LNA and PNA to get the good system performance. So that's the approach I took. Here's what the LO looks like. 10 megahertz reference over in the left-hand corner, upper left, feeding the ADF 4351 development board.
Hey, Greg, this is
Yeah.
Al. I don't see your slides progressing forward.
Okay. Anybody else?
People?
I see the title.
It didn't progress, Greg.
Yeah, I see
It
slide
didn't?
one only.
No.
Yeah, I'm still seeing the title screen.
Nothing's moving.
Okay. Let me stop and I'll start back into it.
Maybe if you hit view at the top and slide view, it might cause it to go into the mode that would work.
Okay, there's.
Greg, do you have multiple monitors?
There you go.
Okay.
We see the objectives requirements right now.
Okay, anybody see the block diagram?
No.
Negative.
Okay, so why is it not advancing?
We just see a window of your Microsoft PowerPoint window with the slide 2 of 15. So I don't know if you have two monitors set up and we're just seeing one monitor.
No, just
Hey, Greg,
yeah.
try clicking on up at the top. It says slideshow. Try clicking on that. Okay, now try advancing the way you were advancing. Yeah,
Yeah,
there we go.
Different ones?
No, that works. Now you got the LO block diagram.
All right. Sorry, guys. Okay, everybody saw this with the approach. And then, okay, here's the LO block diagram where there's a 10 megahertz reference, ADF 4351 board, and an Arduino Uno R3 level shifters driving the SPI bus to the development board. So that's fairly cheap to build all that. You get 3408 megahertz for input to the W1 GHz times 3 board. And then the output of the W1 GHz board is plus 6 dBm, which is a pretty good level as it turns out for input to the transverter board. Okay, the block diagram from the RF perspective, 2-meter IF over on the left. It's bidirectional, so I have relay switching in the 2-meter IF board, W1 GHz board, and then transmit side, it puts out plus 8 dBm. I pad that, use a driver amp and then a PA, followed by a PA. And that feeds an isolator, which feeds the TR relay. On the receive side, basically come in from the TR relay to an LNA to the W1 GHz board. And of course, the LO input to the 10 GHz transverter board. So pretty straightforward. On the control side, I used a 4-pole double throw relay to get switching for 8 volts, 24 volts, 12 volts, and 12 volts. And I didn't need to put in a sequencer in this. Well, if it got any more complicated, I'd probably need to do that. I included a 12 to 24 volt converter, DC to DC converter, and then separate LM7808s for the Arduino and the transverter board and the ×3 multiplier. And I run the PTT to a front panel switch so I can ground it with that switch to do a manual transmit if I'm need to. Okay, there's a picture of what it looks like, and I labeled a lot of it, but not everything. The W1GHz transverter board is in the upper middle section, and you can see the 1/2-inch pipe cap filters on it, 2 on transmit and 2 on receive. And then the received line goes over to the LNA, which is on the left, and the transmit side goes to the attenuator and then the drive ramp, and they're mounted on the back panel. They can't really see them very well in this image. Upper right is the 2-meter IF board, and I used a bunch of 39 ohm 2-watt resistors to get pretty close to 50 ohms, and that's to attenuate the transmit signal. And then I always include a receive amplifier in there, and that's what some of the other circuitry is with the relay. Lower right is a 10 megahertz reference. Many of you will recognize the Arduino symbol there from the Uno. And then I mount the ADF4351 eval board or development board on top of another prototype board and include the level shifters on that. And then that feeds the 2 pipe cap ×3 multiplier between the transverter board and the IF board. Over on the left are some regulators. Those are mounted to the chassis, terminal strip, lots of wiring. And then the TR relay is about as short an RF run as I can make it to the output to help performance on that. You can see the isolator there just to the right of the relay board. Okay. Sure to ask questions if you have them as I go along here. The 2-meter IF interface attenuates the signal. I can take anywhere from 2 to 10 watts. And there's a capacitor to adjust the level to the transverter board that I use. And then the receive buffer amplifier, which also helps protect the W1GHz board in case you transmit into the IF when it's in the receive mode. Also has TR switching. And I've used this interface of many transverters over the years, and it works well with the Yaesu FT290R that I have for roving. The W1GHz transverter board is a nice compact way of getting the basic functions in. What you see from the bottom view are the separate transmit chain on top, the receive chain on the bottom. Each has 3 mimics. And over on the left-hand side is the mixer with the LO input. The IF input is on the other side. And you can see it in this view where you see the pipe cap filters. I think Scott's been in the process of building a 5760 version of this, and we talked about it, but I used a heat gun to get things warm enough to get the pipe cap filters soldered to the to the back of the board here. They work pretty well. This is the ×3 multiplier. Has two filters, different frequencies as it's multiplied up. And it has 3 mimics on it, fairly compact. And nice level of +6 dBm coming out of it when driven by the ADF 4351. And be sure to terminate the unused output on the 4351 to get the right level. Front panel, pretty simple. An LED over on the left to show me that the 4351 is locked. Power meter in the middle. And I have LEDs to show if I'm in a manual, if I'm in TX mode, basically, and then a on-off power switch and indicator on LED on the right-hand side. The Kuhn 2-watt PA module that I used has a nice function where it has the diode detector off of the coupler inside the module, and I use that to drive the power meter. All you need to do is pick the series resistor for the particular meter that you're using. Back panel, again, pretty simple. 12 volt banana jacks over on the left. Fuse. I have a PTT in and out, and that's so I can run to an interface for the signal link, and that allows me to do the digital modes with this thing if I so choose. Over on the right-hand side, you can see the IF connector, just a BNC, and then I've got in and out spigots for the 10 megahertz reference, and that allows me to basically take off that little U-shaped 141 cable and hook up to a GPS DO or another 10 megahertz reference if so desired. Okay, well, how did it do? The W1GHZ board with that 2-meter IF I have shows an overall gain of 29.2 dB. 10 dB of that's probably due to the 2-meter board. I didn't do a separate check on that. Noise figure is about 9.3 dB, and then power out is +8 dBm. So you could use that setup as a basic 10 megahertz transverter, but you're going to be fairly limited in performance. And then when I have the LNAs and the PAs in place, overall gain for the system is 42.6 dB. Noise figure is 2.1 dB, which is fairly respectable for 10 gigahertz. And then +34 dBm for the power out. So it makes a good rover station when you combine it with an 18-inch or bigger dish. So overall, it's about $100 for the W1GHC boards and the parts. And it's fairly easy to get the parts because they're listed. Paul's listed them in a project at Mauser, so you can just, I forget the exact address for that listing, but you can look them up on Mauser and order it as a project. The whole thing fit into an 18 by 17 inch by 3 inch chassis really well. I've got some room where I could add things if I so choose. And I used the chassis for heat sinking the regulators and the amplifiers. So I tried not to add a whole bunch of aluminum fins on the inside part. As usual, adapted to the parts on hand. I ran out of 12 volt DC SMA coax relays, but I've got plenty of 24 volt ones. So I added a 12 to 24 volt converter, and then being careful to make sure that I didn't add a bunch of noise in the system. And it turned out that I couldn't tell any difference with the 24 volt converter in the system as opposed to not using it. Also ran out 12 volt multipole relays, so I used 24-volt relays there since I had 24 volts handy. Used an LNA from an EME 10 gigahertz EME system that I ran in the 90s, and TX amps were what I had on hand. So I think that is the end of it. And any questions?
I have a technical question. How did you label all that stuff on your box? It looks real nice and neat.
How did I label it?
Yeah, the black
Uh,
labeling that you have there.
You mean
TX.
I use a Brothers little labeler with clear with black letters. Is that what you mean?
Yeah, so you just taped them on there. Huh? You couldn't even see the tape, you just see the lettering.
Right. It's turned out to work pretty well. And I kind of use that on everything around the shack. Uh, it's not an expensive labeler, and you can get uh, small, medium, or large print out of the thing. So it's seen use in many projects over the years.
Makes a real nice looking presentation.
Thank you. Other questions?
Greg, if you go back to slide number 8, you mentioned that you had PTT interfaces with FT290R. Would you explain that?
Okay. To run digital modes, I want I used a signal link, Tigertronic signal link. Many of you are probably familiar with that. So that drives the PTT line on the PTT in for the transverter. And then the PTT out goes to the breakout box that I built for the signal link. And that makes sure I get the transverter switched into the right mode before I give any transmit power out of the IF rig. That's probably good for another short presentation sometime down the road. Did I answer your
I would
question?
agree. Is that kind of a sequencer then?
Yeah, right. So it's kind of manual, but it functions as a sequencer.
And you're taking PTT to the FT290R through the mic jack?
Yes. Right. That's what I do.
Yeah, well, it would probably be a good presentation.
Okay. Yeah, it was another little
those are
project in
challenges
itself.
for people, including me, to protect the transverter. So I'm always interested in learning more there.
Okay. Well, I can put together a short presentation for the next meeting. Okay, other questions? All right, back to you, Jim.
All right, thank you, Greg. I can't imagine you being a rover, but I guess you're always that big signal right along with Al and Keith on 10 gigahertz. But if you need any locations, I can sure let you know of a few.
All right.
All right, so I think we are to Logan Dunbar in 5RLD, who is going to take us through some Linux material, and I'm very keen for that for the SDR stuff that we're doing. So Logan, go ahead and take over and